All right, another theorem, Fermat's theorem, not as popular of one, but it does have some interesting things that we should know for calculus in general. This one says if f has a local max or minimum at c, and if the derivative at c exists, then the derivative of c has to be equal to 0. So what they're saying here is if you got one of those absolute max points, or here's an absolute min point, if the derivative does exist there, it's going to be 0. And the reason is it's changing direction there, which means the tangent line's horizontal, and a horizontal slope or horizontal derivative rate of change is going to be 0. Same with a minimum, it's going to be 0. Now, why do they have this part in there about f of c, or the derivative of f of c existing? Because you might have things on your graph where it is an absolute max or min, but the derivative doesn't exist. Where would those places be again? Where does the derivative fail to exist? We've talked about these previously, where the where there is a corner point or cusp. Sometimes we call them cusps if it's a certain thing. So if we had one of those on this, like say the graph went like this, this point right here would be a local maximum, but the derivative there is not 0 because the derivative doesn't exist. So that wouldn't work. The other places we talked about where it fails to exist is if it's not continuous. So if your graph is not continuous, you don't have a derivative. Or also if your graph has a vertical tangent to it, it's not going to have a derivative.